Bence Magyar. Bence is the principal software engineer at Phi AI, and also he is one of the main developers of the ROS to control package.
Yes, the ROS control package is the package that allows us to control the joints of our robots, and it has suffered or experienced, I would say, a major improvement from ROS 1 into this ROS 2 control excellent package. So let's welcome Bence to the stage. Bence, are you ready?
Yeah.
Okay, excellent. So here the stage is all for you. Go for it.
All right. Thanks very much. Hi, everyone. It's been quite an eventful day. I hope you still have a little bit more energy left for this.
Plenty.
All right. So you will see that during my demo, the Jupyter Notebook has a lot of text that I'm going to be skipping over for the most part. It's for posterity. Should anyone want to, reproduce results and follow along afterwards, the text will be there for you to guide you. But in this case, I'll mostly skip the text, with some exceptions, of course. So first of all, I only heard the last bit of Ricardo's intro, but let me just go again. Let me just repeat it. That so ROS to control. I was also glad to hear ROS to control mentioned already more than once today. So that's nice. But for those who are not familiar or not familiar enough with ROS to control, it is hardware-agnostic control framework for abstracting hardware and low-level control for third-party solutions such as Movie 2 or the Nav2 systems. It supports kind of off-the-shelf integration with most simulators, all flavors of Gazebo included, and in general, it allows you to one of the key selling points is that you can go from setup in your simulation to your real robot with very, very minimal tweaking. This particular presentation or demo is going to be, or tutorial is going to be showing you guys how to use ROS to control and the powers of URDF to compose different parts of a robot. So I'm trying to cover the use case where, let's say, you want to build a mobile manipulator, which in this case is you have a mobile base and then you want to add an arm on top. Assuming that you received a URDF description of both components from their respective vendors, you do a little bit of copy paste work with the URDF. You do a little bit of configuration on the ROS to control side, and you should be good to go and use that robot as if it was one single unit. For this presentation, we're going to be using the Tiago robot. The Tiago is a real robot you can buy from Power Robotics. The mobile base is also a separate robot that you can buy from Power Robotics. In this demonstration, I'm going to I basically took the Tiago description that the Power guys made for ROS 2, and I chopped it in two. So you see the bit that we will begin the tutorial with on the left side, and we're going to finish with a fully assembled Tiago. A little bit about myself is that I have so I've done a PhD in robotics. Right now I'm working at 5AI on self-driving cars as a principal software engineer, and I've been around, let's say, the ROS community for like probably over 10 years now, and I've been involved with ROS control and ROS to control since 2015. Right. So let us do a very, very quick crash course on URDF. I think Miguel mentioned that there's a way to turn these off, but it's all right. If you want to feature yourself, and then if you follow me during the presentation, you will show up in the bottom right. So the URDF is how we describe the kinematic structure of our robot. You see that the examples you see here are like I created these snapshots with the Tiago robot, so I should have swapped them around. So on the right side, as opposed to the left on the other image, you see the URDF, or more like the TF tree, sort of let's say highlighting the main parts of the URDF on the right side, and then the full robot with all its tiny details and moving parts on the left side, including sensors and all that good stuff that we're not going to be interested in today, unfortunately. Right. So let's actually start with this. I already opened the code editor. Oh yeah, sorry. Please, guys, open the ROSject now. I've cheated and I even loaded the code editor already. But I think we can take a minute or so.
They have already opened. We already told them before you started. Yeah.
Oh, okay. Another cheat. Allow me to show you another cheat. I'm not sure if any of the previous presenters showed it, but similarly to Sublime, VS Code allows you to do Ctrl-P, but you need to click a couple of times on the code editor, and you do Ctrl-P, and you can just start typing the name of the file you're looking for. Tiago-based unrolled URDF. I have it highlighted also in the text on the left side. What I've done is that typically you would define your URDF as like or more complex URDFs are defined with a set of like macros, XML macros called chacro. But I just rolled out the whole thing for you, so we can have a look at the URDF as it comes, or as in its final form, as it ends up on the param server. So this is really everything that defines the base version of the Tiago, so only the mobile base. I'm just going to look at something that's relevant for us. So among many other things, we have inside this URDF, we will have the ROS2 control tag residing, and then the definitions of the certain command or state interfaces that we have for those joints. At the same time, we can look for the same resources in the URDF itself. I just scroll down a little bit. So we'll see that the wheel right joint is one of the wheels. It's a continuous joint. It's connected to a suspension link, and then there's a wheel right link that actually has the mesh. So now that we have, so in your free time, feel free to explore this file. It also has all the references for gazebo adding inertias and friction. But for now, I'm going to click on this icon on the top right to just copy the whole thing and open a shell. I've also included, if you see me typing, if I get desperate, I'll start just typing in the terminal. That's how you can tell I'm desperate. And if you see me just type S, that's an alias I included in this bash RC of the ROSject for a quicker sourcing command, because I'm just tired typing all that stuff. Right, so this should load up. Eventually, we're going to get an RViz in the graphical tab. What I'm expecting to see is what you can see on the screen. So it's the mobile base of the Tiago robot. Nothing too fancy. Let me grab the joint state publisher as well, so we can play a tiny bit. It's really not a great presentation at this point here. Let me rotate. So if I rotate that joint, you see that the axis in TF, or that coordinate frame in TF, is also rotating along with the joint. Very nice. Hope you're not too impressed by it, because we're going to move on. We're going to do a ROS to control crash course now. So there's no, don't be too worried if you don't remember all the details here. So the whole point of ROS to control is to abstract the hardware interface from the controller implementations. The controllers will get abstract kind of, we call them joint interfaces currently, which could be a position interface of a joint or a velocity interface of a joint, or perhaps both. Similarly to state interfaces, sometimes these, it depends on what hardware you have, what your hardware will expose to the outside. We have a controller manager that takes care of controllers not trying to grab the same resources at the same time. also helps us loading and configuring these controllers. And then on the underlying part, we have a resource manager, basically, which takes care of all the hardware components, which are all plugins, essentially in a kind of a plugin system where they declare, or let's say they contribute their exported interfaces to this resource manager. Unfortunately, what we're going to do, unfortunately, most of the fancy hardware plugin stuff is irrelevant for the Gazebo's case, because in Gazebo we have a perfect robot that has all the interfaces. So this is, I'm just highlighting a part of the URDF on the right side. It's in the ROS Jack, so it's just for my own convenience that I don't need to look for this specific section again. So you'll see that here we define that we load the Gazebo ROS to control plugin, and then we define which joints this plugin should be controlling in a simulation. We also define, it's also possible, you don't have to define transmissions. For instance, if you have a gearbox or something like that, then it can apply the appropriate reduction rates both to and from the actuator itself. And you can also define, if you have certain sensors, you can also make sensors available in the ROS to control side, so you don't need to publish something to a topic and then wait for it to come back, and then all your real-time reliability or just simply reliability conditions are broken on your robot. So you can hook those up into ROS to control directly as well if the controllers need them. Right. Now we're going to launch a simulation and have a look and basically explore what we get with the Gazebo simulation for this mobile base. We're going to be using standard ROS2 or ROS to control CLI commands. So I opened another terminal in anticipation of using them. This one is starting up the robot in Gazebo. I'm just going to take a sneak peek. I'm not even here. I'm going to take a sneak peek at the Gazebo tab and just wait for this guy to load up. But I won't really be. I will not really be. I won't leave this open. Okay, so this is open. Great. Can put it away now because I'm only interested in this boring command line stuff. So first thing first, we're going to list the hardware components that are available. So this is a custom CLI command for ROS to control. By the way, with ROS2, you can do your own things. So should you want to develop your own framework, you can do the same thing with the CLI system of ROS2. So we're in Humble. There were a few bugs that we fixed since then. So this one's just plugin name missing. It's actually there. But so what we can see here is that there's this ROS to control Tiago system that has currently 2 command interfaces available, and which 2 velocity interfaces for those 2 wheel joints. Both of them are available, and nobody has claimed them yet. The same results are in the Jupyter notebook. I'm going to run another one. We're going to be listing the controllers that are in the system, and this right now comes back with a whole lot of nothing. I'm not happy about that. What's going on?
The controller didn't load on the simulation, I think. Can you try to check? And maybe relaunch? Maybe it's a matter of timing or something.
Yeah, let's do that. Maybe I'll leave the Gazebo window open for good luck.
Don't need.
Oh, this one says that it loaded it. Okay. See, I needed it for good luck.
Okay.
There you go. Thanks, Ricardo. So yeah, as you can see, now we have 2 controllers loaded. Also, caveat with ROS to control, we created this kind of, not really, it's just a nomenclature. The controllers that don't actually control anything, we call them broadcasters. So that only basically report things to the ROS system. So one of them is, the most common one is the joint state broadcaster that reports all the joint states. So this one is loaded, configured, and it's running. The mobile-based controller, however, is unconfigured. So something's off with that guy. It doesn't seem to have the right configuration. So I'm not going to look at it in the terminal, but if you looked, you could find that the mobile-based controller complains that the wheel names parameters are empty. So we are going to fix this now. So I happen to remember, and also took notes in the Jupyter notebook, that there's a mobile-based controller.yaml file which hosts the configuration for this. And I also took the liberty of cheating a little bit. So I copied the contents that we want, except for a few bits. So a little bit of mental stretch. Now we need to remember how these joints were called. I think it was like wheel right joint, right? And of course this one's called left. Hopefully I didn't screw this up, and let's just relaunch and see if the controller is now happy. See, I do make you guys work a tiny little bit that's not written in the ROSject. Yeah, let's see if that controller is happy. Amazing demonstration. The controller now says it's active. Maybe it's not the best demonstration you've ever seen. Don't worry, it will get better. So let's just run the same command to see it change a little bit. So see now, instead of unclaimed, it actually says that it's claimed, because now there's a controller that claimed that resource. So no other controller that would require that resource will be able to launch. And there's another command as well, which lists all available hardware interfaces. So everything that was configured. The other one, the hardware components, just lists only like command interfaces. All hardware interfaces, this will list every single thing that exists in the system, whether it's claimed or not. The claimed ones will be highlighted, or the kind of exclusive ones will be given the same information, whether they're available or claimed. But the state interfaces would just be a list, because anyone can claim these any number of times. Right. Oh, I'm a little bit out of order. I was supposed to only show you guys that it's active now. As another feature of ROS2 control is that every single controller also implements a standard ROS2 node interface. So I can also just do a ROS2 node info on the mobile-based controller, and it will come back to me with all the useful usual information. So you see the topics that it subscribes to, you see the topics that it's publishing to and their types. Very familiar. You'll see the CMD vel topic here already. And now, should everything go well, I can actually also make this robot moving gazebo by doing the poor man's key teleop. So I'm just basically publishing a speed command to the controller, and it's off. That's basically to prove that I was not talking nonsense, guys. All right, let's move on really quickly, because I think I'm just right on time. So I'm gonna. Oops, I'm sorry. That was a bad muscle memory.
No worries. We are covering you.
Now it's time for some advertisement, Ricardo.
Okay.
Oh, hey, time for some advertisement. Can you see my camera? Wait, while this loads, let me swap back here.
We can see you, and before we could see your screen.
Yeah.
The rush is loading. So now we can see you. Oh, what is that?
There's of advertisements.
Oh, what is that?
The Flesh and Machines.
Ah, the Flesh and the Machines. Yeah. Excellent. The book that we were discussing during the discussion about the robots of the future. Oh, excellent.
So maybe this maneuver just invalidated my terminals. We'll see. Let me scroll back down to where I was. Now we're going to jump, switch gears, and we're going to go for turning this into a mobile manipulator. So just as before, I have an unrolled version of the URDF of the full robot. One of the key differences, if you have a look at the Tiago base URDF, is just let's say it's 1100 lines. The full one, which includes the arm and the torso and everything, is 2100 lines. So yeah, a tiny bit more. There's a lot more sensors, an arm, a head, a torso, doing all those things. And if you look a little bit inside, then you'll see that now we have parts of the arm kinematics. So there's definitions of the elbow, visuals. You see you have joints, revolutes alongside with their limits, damping factors, all these kind of things. I am going to go ahead now and switch back to the left again. So this is basically just to prove that now in theory we have a setup where we also have a setup where we have added these. On the left side, you can compare to the previous much simpler version. This version of the ROS to control tag includes every single joint of the previous setup, which is up to this point. So this was the mobile base. And now if I scroll a little bit down, then now we also have a torso joint. We have we have the joints for the two joints for the head. We have 1, 2, 3, 4, 5, 6, and 7 arm joints, and we have 2 for the gripper. And you also have a kind of like a virtual joint for the for a force torque sensor in the wrist. Now that we know this, we actually need to put this into action. So for this tutorial, I took full advantage of the already existing ROS2 setup of the Tiago, and I just hacked it a little bit so that we don't have to work that much to make things work. But I'm actually explaining how to hack it back. So now we get the rest of the robot back. So we need to open the ROS robot state publisher launch file and jump to line number 50. All of this is also written in the text. I don't know why I'm pointing at my screen. Right. So, okay, we're right here. So only thing you need to do is to comment this guy and uncomment this other one. So I introduced this very hacky setup here, just for convenience. Right. And now I'm just going to copy this command, run it, and as before, now we have a robot static. There's no simulation. This is just running the robot state publisher with this UI. There's no control. There's nothing actually running here. It's just a mock-up of what if we had a robot like this with this URDF, and we're able to rotate some joints. Now, in order to jump to the ROS to control part, I'm going to run so this was the only change that was needed to launch the same setup in Gazebo. Ooh, that arm fell. What could have gone wrong? Let's have a look. So same deal. But I need to list the hardware interfaces. There's a ton now, and it seems that nobody is controlling anything other than the wheel joints. All of these are bright blue, and these are darker blue. So sorry if it's not really visible. So yeah, we need to do something about this part. Let's have a look at the controllers as well. We're doing a bit of investigation. By the way, I found this exercise really useful because, like, normally when you work with the real robot, you would also go through the same kind of rituals. So see, the problem is we never even had any other consideration for any other controllers because we haven't changed that part of the launch files. So let's do that now. So there's the Tiago has a file called default controllers. .launch right there. And we need to go to line 72, all written in the text on the left side. So cheekily, I added all the configurations are actually already uploaded and part of the file. You just need to uncomment them so that we actually add them to the launch file properly. This adds a torso controller, a head controller, an arm controller, and after a little bit of hacky stuff, an end effector controller. This is kind of like a dynamic part for the Tiago, which has different variants with different end effectors. For our use case, we need to save. Oh, we don't need to save it, as Ricardo told me that this environment saves automatically. So we only need to restart Gazebo now, and hopefully the arm is not going to fall, or will it? Oh, it's still falling. What's wrong? Let's list how we're doing in terms of controllers. So it seems that we have a lot more controllers, and most of them are active, except for the ARM controller where something's wrong. If I scroll around here, I can probably find it, or I can cheat and just tell you guys that something's wrong with the ARM controller. Let's have a look. Let's have a look at the configuration first.
Okay,
So
10 minutes.
ARM controller, yeah.
10 minutes.
That's nice because on my timer I only have 5 minutes left. So the ARM controller config file doesn't have anything useful for the ARM controller. So let's try to fix that. I added a little bit of a hack here again as before. So this is how it generally should look like. One thing I know already is that we want to control the arm in position, and we want the feedback to be in position. So I'm just going to put position there. And because we also know that coming back here, that those joints have all the interfaces. So I'm just going to pick position for convenience. And here we need to write a list in YAML. If you guys are really adept at writing YAML, well, almost. Okay. All right. Let's see. How many joints did we have? We had 7, right? So I'm going to do the template matching. This should be our configuration. I can, of course, also omit one of those joints, and that would just mean that the controller that we're configuring is not going to be controlling the joint of the robot. The robot may look weird and have a numb joint in its arm. But whoop, as you can see now, that we're definitely doing something to the robot, something different than before, because now the arm is not falling. And there's some stuff is moving there, which means that the force torque sensor is active, so forces are acting on it. All right, let's verify this. First of all, let's just list the controllers. So now I see that the ARM controller is also active. Very happy about that. Now let's just list the hardware components. Hardware components are also seem to be very happy. As you can see, I only configured the joint trajectory controller, aka the ARM controller, to claim position interfaces. So the position interface of every ARM joint is claimed. The rest are left unclaimed. And for how the Gazebo plugin is implemented, this is fine. You don't need to claim everything, since we can control things in position just fine. At least in Gazebo. Of course, if your hardware doesn't support it that way, then implement your hardware component plugin for ROS to control with that in mind. Right, listing hardware interfaces. So this lists everything. This one also looks good. I already listed the controllers. There's only one thing left to do, which is another hacky one-liner. Should move the arm. Let me put this back so we see what happens. And now, oh, actually, sorry. Yeah, it's not moving there. It's just moving the torso. Yeah, but for instance, if we wanted to do a little bit, I still have a little bit of time. Let's improvise. What could go wrong?
Nothing.
Like famous last words. I'm just going to change this for sending a command to the ARM controller, and I would try to only send the command to the ARM joint. I'm not sure if this is actually supported with the controller. It should be, but let's see. Maybe now the joint trajectory controller is telling me that I'm silly, and the joints on the incoming trajectory don't match the joints of the controller because it's expecting me to send it command for every single one of them. And I'm not going to do it because that's how sending 7 things here, that's how everything can explode. So instead, I can play around with the torso a little bit. So I can also send it back down. Yeah. All right, guys, I think this is the end of my presentation. If you have any questions, now is the time. I added some useful references at the end of the presentation, including an amazing URDF tutorial by Josh Newens, great guy. And yeah, I'm open for questions.
Okay, Bence, thank you very much for your presentation.
Thanks very much.
And
Okay, thanks, Bence. Then now let's start the Q&A section. So attendees, please put your question now in the Q&A tab, and we're going to pick the most voted one to ask Bence. Okay.
yeah, and already plenty of questions here. So let me start with one from Roberto Sagert, that he says, if I plan to control my own mobile robot using ROS to control, do I need to program a custom joint state hardware interface to be able to have a joint state broadcaster? Or does it exist an already pre-made solution?
So the catch with kind of hardware abstraction is that the abstraction layer is different for every single piece of hardware. So currently the framework supports sensors, systems, and actuators. The difference between these are that essentially like a system component will have read-only and read-write interfaces available. So this is your most general one. Sensor components will only support read-only ones. So for instance, if you have an IMU, and you can do like a couple of, the cool thing with this is that you can capture some semantics, for instance. And so like fast forward to a ROS message, for instance. And the actuators are kind of like something in between where you get like a gem that it knows how to control just one joint.
Okay, yeah, then that means yes.
So you still probably need, yeah, thanks, Ricardo. You probably still need to do a little bit of work to implement one of these components, but it shouldn't take a lot. If you have a topic-based setup already, then there's a solution for that provided by the guys who work for Picnic. I'll look it up in the meantime and mention it.
Okay, then let me ask you another question, asked by the same guy that is being voted by the people. Then you need to refresh that.
Yeah, since probably you can still see my screen.
No. We can see you perfectly.
Oh, no, you can see now my.
Yeah. We can see you. No problem.
All right. So there's just to answer the question properly. So there's
yes, go ahead.
Topic-based ROS to control is the name of that package.
We are sharing your screen now. Topic-based.
Yeah. So this is what you're looking for. It's also been released, I think, to Iron and Rolling. So this is like kind of like a quick boilerplate setup.
Okay, excellent. Okay, then let's go to the next question by the same guy, Roberto Segers, that he says, in practice, how important it is to learn about creating a custom ROS to Gazebo, ROS to control plugin? Or are there already standard plugins?
It's not important because also we didn't create one here. There is just one plugin per Gazebo. So there's Gazebo Classic and there's the new Gazebo, which used to be called Ignition. So there's a plugin for that. The only thing you need to do is configuring it.
Okay.
So as here, like you just tell Gazebo which joints of that robot you want to control with ROS to control. That's it.
Exactly. So then if, for example, they have a simulation of their own robot, then in Gazebo, they will use this plugin that shows the proper topics and for their control programs. And then in the real one, they will have to implement their hardware interface and exposing the same topics.
Yeah. If it's a custom robot.
If it's a custom
If
robot, yes.
If it's not a custom robot, for instance, I think the guys at Robotics are planning to start selling the Tiago with ROS 2 very soon. So there will be many robots that will come with their ROS 2 control interfaces already set up.
Exactly. So that actually the final goal of ROS 2 control, right? So we buy a robot and then it's already with a ROS 2 control.
It comes with a URDF and it comes with a hardware plugin. And
Exactly.
you just put those in there and you should be good to go.
Excellent. Okay, then another question from Klaus Lex that says, also wondering about the best practices for modular URDF creation, like switching robots from platforms, mounting different sensors, and mounting systems.
Yeah, so definitely don't do what I did during this presentation of using one ginormous URDF. I used it for only demonstration purposes. But normally, you would use the XML macro functionality. So you'll find it with Chakro, XACRO.
Chakro, format. Yes, we were, for the audience that doesn't know, so we were discussing, you and I, about this because you proposed to do it in a single file. And in terms of lecturing or showing, because otherwise you would have been jumping from one chakra to another to include, and then that would be a mess for the audience. So now in a single file it's easier to show.
Yeah, so if you can have a look at my screen.
Yes, please. Let's switch.
I'm just showing.
Switching, and there it is.
So I just opened the Tiago URDF.chakro. Which if you look at the Tiago, so this is all on GitHub. If you look at the Tiago packages, you will find this file, and this I would consider a really, really good example of how to do composable robot URDFs. Excellent. So you see that, so you don't want a four-stock sensor? Okay, it's even parameterized at launch time.
Okay, I think we have time yet for more questions. Then we have a question from Marco Pedretti that says, how far is ROS 2 control from being used in a real-time scenario?
Depends on your definition of real-time. But I think so far we got some feedback of people using ROS 2 control on 100, 200, 400 hertz systems. Wow. I think actually there may be some bits that are not technically real-time safe yet, but there's definitely something that we've always been pushing for. But there's definitely already been quite some deployment out there in, like, imagine all types of field robotics having some robots running ROS 2 control.
And then, then related question is by the same guy, Marco Pedretti, that he says, how big is expected the effort to bring a ROS 2 control based solution into the real-time world, ready to be certified as a real-time compliant RT safe?
It's a very nice question. We didn't really look into certification of any kind. If we were a company and we have unlimited resources, yes. Not unlimited, but some resources for that, then absolutely. But it's a fairly small developer community running this now. So yeah, no certifications. Sorry.
Okay. So start with Marco. So you're interested? Maybe you can start the effort.
Actually, exactly. If anyone, the other thing I want to actually a bit of a shout out. The other thing I wanted to say is that there is a working group for ROS 2 control. You can either check on ROS Discourse for the bi-weekly announcements that I make, or look at the ROS events Google Calendar, and every single meeting is also listed there. And if you have any topics that you would like to discuss, just show up.
Okay. Okay, then said there. Let me see here some other questions that we have. So there is Klaus Lex that says, I fiddled with ROS control boilerplate previously and wonder if there is something similar or how to go about this for. Okay. So he's talking about the question of Robert Seguers about the interface unit. And then let me see another question.
So, but by the way, to answer that question, halfway answer that question, I think if you go back in ROS Developers Day by 2 or 3 years, we had a presentation of going from ROS control to ROS to control.
Yeah,
and
2 years.
Drawing some parallels there. But in terms of like the ROS to control boilerplate, here you need a lot less work to get to a working robot. That's why we wanted to make hardware components like kind of like plugin based.
And do you have any? For example, you are mentioning in your presentation about Power Robotics and the Tiago robot. And do you know about if they are using or any other humanoid robot using ROS to control in a ledge robot?
In a what robot? Sorry.
In a ledge robot, a robot with legs. And a humanoid robot, maybe are you aware that ROS control being used?
ROS control or ROS to control?
ROS to control, sorry. ROS to control.
So I don't know, but I don't see why it couldn't run it. I know that the guys, for instance, at Robotics have been working also a little bit on adding support of ROS to control to the Talos. But I can't say much on that since I'm not working there.
Okay, then here there are some people asking some strange questions that, but I don't know. So maybe they want your advice. So let me ask you one that is unsure. I mean, no question is bad or good. It's just the subject that
it may just be not for the right for the session.
Exactly. But as you are a super ROS expert there, then maybe you can help them. Then Anshul says, any good practice to get good odometry accuracy?
Depends on the robot. An underwater robot will have totally different odometry issues than a mobile base.
Yes, exactly. So
just do your gamma filter well and add your particle filter well and add more sensing.
And the sensors in the wheels
and more. It's more different modalities of sensors. I think that's always key with robotics. That's what a lot of people overlook.
The information from all of them into a single odometry.
Yeah.
Okay. Then that's the last question. There are more, a little bit more like it doesn't fit into the ROS to control, but maybe it's because they are beginners maybe, and then they don't know exactly where to put every part. So please don't feel any kind of a shame of your questions. All the questions are correct, but I don't think that we should ask those questions to Bence because they are not related about the ROS to control. You can ask those questions in the chat to anybody else that is there because there are plenty of ROS experts. Then that's it. Bence, thank you very much for everything, for your presentation, and see you around the world.
Thanks very much, guys. See you around. Bye-bye.
Bye-bye. Thank you, Bence. Okay, attendees, now you should see a small box appears. So there's the place you can rate for this presentation by Bence Magyar. So please take a moment and rate this excellent speech because at the end of the conference, we're going to announce the best speaker of this ROS Developers Day.
Yes, excellent. Yeah. And now we have to go to the next speaker.
And before that, remember to open the next project.
Yes, and the next project should appear. The button is already there. So you can see on the data section and the data docs, if you are inside the ROSjet or if you are just in the general streaming page, then it's beneath here. Yeah, beneath her.
Yeah. Okay. So while we're waiting the next speaker ready, let's have the final prize quiz challenge. So in this challenge, the winner is going to get an ROS Developer T-shirt and also a coffee mug, which is sponsored by Robotic Automation.
How does it work? Is this challenge for winning the T-shirt and the mug is very easy. You have to watch a video that we are going to show right now for a few minutes, and then at the end of the video, you will see a question related to the video. The first person that correctly answers that question on the chat will win the T-shirt and the mug.
Okay, good luck and see ya.
So Marco Pedretti, this is your chance to win the third in a row. Because we have Marco Pedretti here in the chat and showing us the T-shirt and the mug from the previous years, 2 previous years. So now is your chance. Let's go.
Let's go.